everybody, I'm Miss Cooksey, and today we're going to be taking the things we learned about in the last couple lessons and combining them in this application lesson. We're going to be applying quadratic functions. Quadratic functions are useful whenever you have projectile motion. So anytime there's an arc, if you throw a baseball, a football, if you throw something off a roof, if you jump, if you bounce a bouncy ball, those are all modeled using a quadratic function. Anytime there's an arc going up or down, a dolphin leap is a quadratic function. So here is a graph of a small rocket showing the height h t seconds after it was launched. The equation gives the path of the rocket. H equals negative 16t squared plus 128t. Here we are given the graph, so we're going to actually be using this graph, and I'm going to move my face so we can see the whole graph to answer all of these questions. First question, how long is the rocket in the air? Well, if this is where it starts in the ground and it goes up and it hits the ground again, it is in the air for 8 seconds. What is the greatest height the rocket reaches? Well, if we look at our graph, the greatest height is this vertex, and that is at 260 feet. When does it reach that height? So let's look at what time that vertex is. It is at 4 seconds. About how high is the rocket after 1 second? Okay, well, let's look at 1 second. Seems like it's about 120 feet. Maybe it's 100. Oh yeah, it is 100 feet. After 2 seconds, how high is the rocket? Okay, so at 2 seconds, let's go all the way up. Seems like our rocket is just under 200. That seems like it is 190 feet. At this point, is the rocket going up or down? Well, let's think about what's happening with the rocket. It's going to start on the ground, and it's going to get shot off, and then land 8 seconds later. So at 2 seconds, the rocket's still going up. After 6 seconds, let's find out how high the rocket is. It's also 190 feet. But at this point, the rocket is going down. This is how we can use a quadratic graph to help us figure out different components of a quadratic function. And it shows how we can apply it. If you are shooting a rocket somewhere, you might want to know at what time it's going to hit, and this is how we can do that. Here's another question. A ball is thrown in the air. The equation h represents the path of the ball. H equals negative t squared plus 8t plus 3. What is the maximum height of the ball? Well, we're given the equation. We're not given the graph this time, so we're going to have to use algebra to figure out what the maximum height of the ball is. And first, we need to figure out what we're finding. So if we're looking for the maximum height of a ball, that's the top of our parabola, which is the vertex. The maximum height is going to be the y-coordinate of that vertex. Because t is time, that's our x value. So h is y, which is our height. So to find the y-coordinate of the vertex, we're going to start by finding the axis of symmetry. We're going to use negative b over 2a to find the axis of symmetry. b is 8, so negative 8 over 2 times negative 1, which is positive 4. Then we're going to take that number, and we are going to evaluate the function where x is equal to 4. So f of 4 is the same as negative 4 squared plus 8 times 4 plus 3. If I evaluate, I end up discovering that at 4 seconds, the ball is 19 feet high. So my vertex is at 419. In real life speak, this means that the maximum height is 19 units, and it occurs after 4 seconds. The vertex is always going to give you the very top or the very bottom point of whatever your parabola is. Thanks for watching. I hope this video was helpful. Make sure you subscribe so you never miss a video. I'll see you next time.